It is called leaf of faith. Okay, now we'll see leaf of faith. When a function calls the flow of execution that the function works correctly and returns right result is called leaf of faith. In a function call, the flow of execution that the function works correctly and returns the right result is called leaf of faith. When a function calls flow of execution that the function works correctly and returns the right result is called leap of faith. Okay, already we are practicing leap of faith use built-in functions. That means all built-in functions return correct results, correct right results. So we are also practicing leap of faith used in built-in functions. Okay, how to know leap of faith built-in functions? For example, we'll import math module. Now we will test it leap of faith on mathematical functions. Okay, so here math.sqrp of 25. It written right results 25. Okay, that is returns 5.0. Math.sqrp of 144 is here, but the value returns here 1. Okay, that means it gives right results. That's why the built-in functions follow the leap of faith. We are already practicing this leap of faith used in built-in functions. In our functions also to work correctly and returns the right result. Okay, it is improve our leap of faith in our functions. User defined functions. Okay, now we're checking the types. Here, what happens? We call factorial 1 minus 1.5. Okay, 1.5 as a argument. It gives runtime error, maximum recursion depth exceeded. Maximum recursion depth exceeded. Okay, it looks like an infinity recursion. Okay, the recursion base when n is equal to 0, but n is not an integer, we can miss the base case and the recursive forever. If it is n is the 0, n is an integer, it will be successfully run, successfully execute. It gives right results. Otherwise, that means, but if n is not an integer, we can miss the base case and the recursive forever. In the first recursive call, we can n is 0.5. In the next, it is 0 minus 0.5. Okay, from there it gets smaller, but it never be 0. That's why it will be executed recursively infinity times. Okay, we have two choices. We can try to generalize the factorial function to work with floating point numbers. Okay, to generalize factorial function to work with floating point numbers, or we can make factorial check the type of its argument. Okay, that means we can try the factorial function works with floating point numbers, or we can make factorial check type of its argument. That means first of all we check type of argument, then we will done the process. It is the one of the way to correct the function, or to generalize. That means the factorial process works on floating point arguments. Okay, we can use built-in function instance to verify the type of argument. Okay, the built-in function is there is instance. It will be checked a given argument, either integer or other, integer or other, and it gives the one of the message. While we were at, it also makes sure argument is positive. Sure argument is also positive. Okay, we'll add some more coding inside the factorial and we'll correct it. That is, if not is instance, not is instance. That means if it is float, it return to the false value. It return. Okay, it's not return false value, so it's not execute. Okay, it's print the factorial is only defined for integer. That means it is comes true if it is gives float value. Float value, that means it's print. Not means it is, if it gives float value, it return true. Sorry, it return false. Then if not is true converts into, sorry, true converts into, sorry, it return false. It's convert into true. That is, suppose n value is float is there, it returns false value. False value converts, not is the one of the operator. Logical operator. Its operator converts false value into true, so its print factorial is only defined for integer. Return none. Suppose my n value is minus, negative values are there. Here checks elif, that is alternative conditional statement, that is elif n is less than 0. Print factorial is not defined for negative integers. Return none. Else if n is equal to 0, return 1. Next else return n into factorial of n minus 1. Okay, now we'll see this code, adding some more code in our function. It is execute right results for all arguments. So our function also follow the leaf of faith. That's why we can make any type of the user-defined functions to follow the leaf of faith concept. Okay, now we'll see the adding some more code and how to follow leaf of faith in our function. That is here, add. Okay, we'll copy this one, our function programming, and we'll add it. To this, okay. Copy it. Paste it. Here we'll add if not instance. Not is one of the keyword. It is the logical operator. That means it's after not comes true, it's convert false. If it comes false, it convert true. If n is not integer value, suppose if it is not integer value, is instance. Don't bother about the instance. Okay, instance is the one of the free built-in function. It is checks comparison of n given. Okay, is instance, n is int. If it is int, it trues. Okay, it's convert true, then execute the else. Here print factorial is only defined for integers. Okay. Okay. Next, return none. Return none. Next, what about this elif? If elif what about n less than 0, then print factorial is not defined for negative integers. Next, check it elif n is equal to 0 colon return 1. Next, finally else what is return n into factorial n minus 1. Okay, this is the function. Something mistake is there. If is not instance, print factorial is only defined for integers. Okay, here put this one, enter, is written 0. Okay, enter, okay, it's correct. Okay, here also indentation is very important. Indentation. Enter. Okay, this indentation. Okay, else if enter elif n is equal to 0, then return 1, else n minus 1. It is not completed. Define factorial n. Okay, this indentation is correct. Follow correct indentation. Okay, enter, return 0. This correct indentation. Enter. Okay, correct indentation. Here is indentation. Okay, this is now comes as Okay, okay. Yes. Completed. Okay, sorry. Here we're missing some more code here. That's why it given. Okay. Now invalid syntax. If it is okay. It is indentation errors. No problem. Copy it. Paste it. Where it comes. Yes. Yes. Is indentation written. Okay. Enter. Okay. Else. Enter. Indentation problem. No problem. Okay. Complete. Now we'll check the our factorial. Factorial. Okay. First of all, 0. Written 1. Okay. Factorial value of 5. Use 120. Okay. Factorial by using floating point value. Okay, sorry. Factorial is only defined for integers. Okay. Now we'll test with str strings. Factorial is only defined for integers. Factorial minus value -7. Factorial is not defined for negative integers. That means our function is now correctly working. That means our function followed the leap of faith. Leap of faith. Okay, this is about the leap of faith. Okay, up to this end of this second unit. Okay, day after tomorrow we'll start. We'll start the third unit. Third unit, that is entire covers the iterations and strings and lists. These are the concept covered in third unit. Now come to the interaction session. Okay, the first base case handles non-integers. The second handles negative integers. Both cases, the program prints an error message and return none to indicate that something went wrong. Okay, factorial. Right, it gives factorial is only defined for integers, none. Print factorial -2. Is also factorial is not defined for negative integers. It's also written none. Okay, in both get fast both checks, and now n is the non negative integer, so we can prove that the recursion terminates. This program also demonstrates a pattern sometimes called guardian. That means this program mainly a pattern follows, sometimes it is called guardian. That means any type of argument you pass is not given any error. Okay, the first two conditional act as guardians, protecting the code following from the values might cause an error. The guardian makes it possible to prove the correctness of the code, mainly